So how are we optimizing our right of way? We basically want to reduce the profile of the whole transmission line. If you look on the top left, you'll see a bare wire 69 kV that is constructed in a vertical construction. And you can see from the top of the pole down to the lower face, we got about 16 and a half feet. Right next to it, you have 69 kV spacer cable. And you can see from the top of the pole to the bottom of the bundle, it's 5 feet. So we're essentially saving 5 feet of vertical space. Now, the first job we did at OPPD, we wrote a IEEE paper with the OPPD engineers and discovered that we were reducing the pole height not by 5 feet, but by 21 feet. That's a heck of a lot of vertical reduction. So the answer is, yeah, it's going to depend on what you are comparing. You got horizontal, you got vertical construction, what kind of poles you use, and where are your insulators, what kind of clearance you need, are you going over railroads, et cetera, et cetera, et cetera. But in this case, we saved 16 and a half feet. And if you can see here, we've got 69 kV in a lot of residential areas. This is a Maryland area, and you can see the new spacer there on the right. There's an interesting photo. Here's a situation where there's another Maryland Pepco transmission line, 69 kV in a right of way. They had every 6 months they do a helicopter patrol. Helicopter radioed in. You got a tree down on your line. The line's out. They said the line is not out. So they sent people out, trouble men. They took photos, cut the tree down. No problem. No damage to the conductors. If that was a bare wire line, it would be on the ground, and the underbuild would also be on the ground. So that was up there somewhere between 1 day and 6 months, probably somewhere in between that. But that's very comforting from a reliability statistics, reliability index point of view, that we have a tree down on a massive transmission line in a major metropolitan area and no outage. Well, that's exciting. We got urban applications. OPPD, this was going to a smelter plant. So that was kind of interesting. Here's another urban application, if you will. This is CNEL in Guayaquil, Ecuador. And what they're doing is they're energizing a tram. And this tram, you can see the right side photo, is bringing people in from across the river, thousands of people, so that you're not having those same thousands of people sitting on the highway, coming over the bridge in the morning and jamming everything up. This is brilliant. There was no space for a 69 kV line, but we were able to snake it in here with spacer cable. So this is a nice little application. Here's Louisiana. There's the city of Natchitoches, triple circuit. We had 132 on the top and 15 kV on the bottom. They framed this up for 69 kV bare wire. The line department said no. I think they said hell no. And they accepted spacer cable. So we got the spacer cable in here. This is a loop that's been around. As soon as we built it, we got hit by Hurricane Katrina. Survived. Had a couple of distorted spacers, but it survived. It never got shut off. And in 2020, it got hit by Hurricane Laura. So very, very happy with this, and so is the client. Here's a national park application. This is Parque Villarrica. It's in the south of Chile by the ring of volcanoes. This is a ring around the city of Pucón that goes through the national park. It's a very important national park. They got ski resorts and lakes and all kinds of really cool stuff here. But we basically built a 69 kV line on top and a 25 kV underbuild. And their EPA, which they call CONAMA, Committee Medio Ambiente, basically were with us every day for 6 weeks. They followed us around. They measured everything. We had to have short spans. We had to have short poles. The poles were, I want to say 45 feet. The spans were something like 35 meters. We had to paint the poles a certain green so it fit in with the environment. But very happy. And what I never said is that even though there's a volcano here cut out of the picture, Even though that volcano hadn't erupted in 100 years, in 2016 it erupted and blew ash all over the spacer cable systems. And we went out and took a look at it, and it survived very nicely. So we're happy with that. Yeah. And we've got, wetlands. This is National Grid in Massachusetts. This is a double circuit 69 kV ring running around Western Mass, if you will. They had some outages on this. The trees came down on the bare wire, and it was not received favorably by the clientele or the Public Utility Commission. Have a transmission line, the distribution line go out. You may have 100, 200 people without lights. You have a 69 kV loop go out. You're in trouble. You've got thousands of people out, and it's really unacceptable. So the conversion begins. This is about 2015. Tropical application. So we've got, especially given all over the Caribbean and tropical areas around the whole planet. But here's the 69 kV line we built through a national park and the country of St. Lucia, which is in the lower Caribbean at a utility called Lucelec. So very, very happy about this. It's operated real well. We're not talking about configurations here. This is what a 90 degree corner pole looks like. We snatch off both ends. That's what a horizontal transition looks like. We can have horizontal transitions or vertical transitions. Pretty well. So up until this time, 7 years ago, we'd only built 69 kV in spacer cable. We have a project in Jasper National Park, which is in Alberta, Canada. It's a UNESCO World Heritage Site. It's a very special place for our planet. That city in the middle of that national park is supplied by a diesel gen plant for 45 years. It reached the end of its useful service life. They wanted to change it out and refurbish that diesel plant. Public Utility Commission said, no go. It's not going to happen. You got to connect that Jasper to the Alberta's electricity grid. So this project was met with tons of challenges. I mean, topographical challenges, geological challenges, environmental challenges, and soil. We were unable to directly embed poles. It was rocky, real difficult project. But first 69 kV tree wire installation in North America. So it's a bit of a piece of history here for us. This is what a tangent pole looks like. We're basically using line post insulators with suspension clamps and IPCs to hold those phase conductors. That takes a little bit of explanation. Here's a light angle pole. Here's a heavy angle pole. They put it on an H-frame, but they still had that super compact configuration, and a dead end pole. Since we're stripping it, we had to strip it. We had to bring those phases out back to bare wire.